So funny story about this next one. Couple funny stories. And one not so funny story, I guess. So originally this was supposed to be 3 presenters. Ari Rizzatano was unable to make it due to other things outside of her control. Say nice things if you get a chance to her. It might help. So these 2 are left, and Ari did help out with the presentation. So I think they mentioned that. But that's not the funny story part. The funny story part is I'm just checking in to make sure all the speakers are okay and they understand how the event's going to go. And then all of a sudden I get this one back, oh, by the way, I cut my thumb off. So that's never happened with a JSConf ever. And I kind of missed it on the first read-through. And so I'm talking with him he's like, I am at the hospital. Don't worry, I'll get discharged tomorrow. Tomorrow being the day before he leaves for his flight. And I was like, discharged from the hospital? Why are you at the hospital? And he's like, I cut my thumb off. And he sends this picture, and, well, it looks a little bit better than it did, but not much. So one of our robotics speakers might be building his own robotic arm today. But I know I've looked through the slides here. I think we're good. And I know you're all in for a wonderful treat. And without further ado, the robotics presentation.
Okay, are you guys ready? There's other sounds. This is how I want you to feel coming into RobotsConf. Okay. So as Chris mentioned, Ari couldn't make it, but she's with AppNeta, and she's done some really cool stuff in robotics. She did an RC car conversion, but she couldn't make it for family reasons, but she did help out a lot with the presentation. And then, Jonathan, why don't you tell us a little bit about yourself?
Yeah, sure. I've been making robotics since I was a wee person. Really bad with robots, but they did stuff. And then I've been doing robots more actively since NodeBots came onto the scene. So I really got into it because Johnny 5. Yeah, clap, it's cool. Two, I work for Google and I do stuff with APIs. So all my bots are connected devices with APIs and they do OAuth, which is scary stuff. But yeah, and I'm working on the robotics table as well.
Cool. And I've kind of always been a maker. I've always played around with stuff. I haven't really gotten into robotics until this last Vegas NodeBots day that we hosted. We made up a kit and had about 30 people show up. Had a lot of fun. And I've been really into it since then. So much so that I applied to help out with RobotsConf and got accepted for some crazy reason. Thanks, Chris. So we thought we'd start with what is a robot. This one doesn't know who he is. He's looking at his own printout there. The dictionary definition says that it's basically a machine that's capable of carrying out complex actions, especially one programmable like computers. And for practical usage, you see the example there. It says robots can perform certain tasks that are considered hazardous for humans. And you can replace hazardous with repetitive, precise, boring. We basically make robots to do things that we don't want to do, or we want done better, or just for fun. That works for me. So here we have, this is, I forget what this one actually is called, the Kubot, something like that? Sorry? Kukubot, yeah. Wow, very smooth, such precision, much accurate. Wow. But we also make robots to do cleaning for us that simultaneously entertain our pet and us. So this is a cat riding a Roomba, which is, I think, like probably Roombas were designed with this in mind. Because it's like it's got this perfect cat-sized perch on top. This GIF is missing the duck, but just imagine there could be a duck in there too, being chased by the cat on the Roomba. The internet, love ducks and cats and Roombas. DARPA. There's also things. It really creeps me out. And there's like a video where it's like, you know, the guy comes and like knocks it over. Just, you kind of feel bad for it, but not for very long. So unlovable. Look at it. There's some fantastic parody videos though. What makes up a robot? The robot anatomy, as it were. So sorry for before when I said we wouldn't help you figure out how a robot thinks. I was just nervous because I really like you guys a lot. We're going to help you figure out how robots think and dance and sing and all that. But the main part of a robot is the CPU, kind of the brains part of the robot. And there are several different options for this. Sky's the limit, actually. I think you all have Arduino Unos in your kit. It's a very popular microprocessor board. You can program it to run servo motors and things like that, and do everything you'd want a robot to do, pretty much within limits. It's pretty simple. It doesn't do Wi-Fi stacks or operating systems or anything like that, but we have other solutions for it. There are also specialty Arduinos. Here we have like the Romeo, the Spider board or something, and then the Red board, which are basically Arduino chipsets that have extra things on them like motor controllers and power supplies, and just make it a lot easier because they're specialty made for robotics. We have a bunch of parallax bots as well. I think the standard parallax robot uses like a basic stamp set, which is pretty like old school. It's this like limited instruction set basic for programming, PIC microcontrollers and things like that. If anybody wants to do that, you're welcome to.
We actually have chassis for that exact purpose.
Cool, like a zombie chassis, as I would call them. The Raspberry Pi, it has a number of GPIO ports which control motors and things like that. It's basically like a very small Linux computer. It has all of the, runs an operating system, boots up. Takes a lot longer to boot up than a Pi by itself. Jonathan has actually built a robot that features a Raspberry Pi and an Arduino.
Yeah, so I'll have it on display, but it's a Raspberry Pi and Arduino, and run Johnny 5 on it. So I have a node server, actually run Express and Socket.io. So then I have a website that you can go to. It broadcasts its IP, and you can control it with touch interface or mouse if you're on desktop. So you can drive it backwards and forwards and turn around from anywhere on the internet. And it was super easy to do. So if you're interested in that kind of stuff, cloud connected, especially Raspberry Pi is a great base just because it's lightweight, uses little power, and fully programmable.
And why would you use both, like the Arduino and the Raspberry Pi?
Yeah, well, one, I want to use Johnny 5 because I love short circuit better than one, as opinion. But because
help me, Rhonda. Help me, Rhonda. Sorry. It's a great scene.
With the Johnny 5 and the Arduino, the development of the robot is actually pretty trivial. It's sort of, turn on, move forward, and Johnny 5 helps you do a bunch of that stuff. And you could also do multiple boards. One board for, let's say, the arm, and then the other one's for the legs if you're building like a walking bot. So it gives you a little bit more flexibility. And then I get to write full node on the top of the Raspberry Pi, so then I can do the web server, I can open sockets.
So basically, it just makes it self-contained. If he had not had the Raspberry Pi to run the node, you'd have to have a cable and chase his laptop around with it. So cool. There's also BeagleBones, which are kind of like, they're very similar to Raspberry Pis, but they have a little bit more of everything, like more CPU and more GPIO ports. They're also maybe a little bit better built and
organized and things like that. It's a little bit easier to hack on just because the pins are better spaced out when you start getting more advanced with sort of the Linux base.
We have a number of them around, so feel free to grab one and learn about it and use it. Mindstorm, these are like very basic bricks. You program them with drag and drop, like programming blocks, and there's ways of overriding the operating system to use like Lego S, I think is what it's called.
Yeah, it's built by Lego. That's the key thing.
Yep.
It's a whole kit.
They're pretty cool. It's a great way to get started because you can just sort of block the Legos together, and it's really fast for prototyping. And there's a number of upcoming boards like the Tessel and the Pinocchio, which I think we'll have a couple of Pinocchio dev boards on site here, and an Esprino. And these are like, some of them are like run JavaScript natively or almost natively through like a cross compiler. A lot of them are shrunk down like Arduinos that have built-in Wi-Fi and things like that. So there's a lot more down the pike than just Arduinos. And we're going to talk about motion articulation, or what makes robots go. This is Ministry of Funny Walking Walk. So the base thing is a DC motor. It's basically just a DC motor. You see it in a lot of toys. You give it power, it goes. You cut off the power, it stops. You change the wires around, it'll go backwards. You'll see it in a lot of toys. In robotics, you won't see like this size usually because you need like an H-bridge to make them go reverse, but on larger scale robots, like things that are made on wheelchair bases, you will see them because they're just very powerful. But more often in hobby robotics, you'll see what are called servo motors, and they have a DC motor in there and an optical encoder and a number of gears that increase the torque and slow down the motor a bit. It's a lot better for finer control. They come in two varieties generally. Full rotation servos, which can go like, you just tell go 90 degrees that way, and it'll just start spinning that way, at a certain speed, and it won't stop, and reverse. But normally they just go between like 0 and 180 degrees for the standard servos. You can take a standard servo and modify it to be full rotation by just taking it apart and just snipping off a little bit of plastic, and you have a full rotation servo. I believe most of what we have are like S148 Futaba full rotation servos. You can use them for moving tires around and things like that, robot heads.
Yeah, so that's like the best point. The reason why you use a servo motor is for puppet-like movement. So moving a finger, maybe if you're making like a cool mask or like an animated sculpture. They're great because you can position a bunch of them if you have enough pins to an accurate position. So they'll stay, in this position. I can do one more position, but there's kids around. But it's a lot of flexibility with the precision.
They're cheap, yeah, pretty precise, easy to control. I don't think robotics would be around without these, or it'd be like in a very much funnier state. Because like when you look up robot sound.wave or something on Google, that's probably like a servo motor sound. They're very distinctive and cool. Beyond servos, we have stepper motors. They're a little bit beefier in general. Like on the small level, they're more precise. They use like tooth magnets, and they have like different degrees of precision, but like usually like 220 degrees of precision. You can turn them to a certain position and go back, and they have a good amount of energy in them. You'll see these in all of the 3D printers that we have on site here. I think they're all NEMA 17s. You need a stepper motor control board for them, which Pololu sells, or a number of other things like Arduino Motor Shields have some of them built on. Do you have any commentary on it?
Compared to a DC motor, it's very similar. You can kind of use it for continuous cycle rotation. It's a little more complicated because of the different phases of the stepper motor. It just means you got to write a little bit more code, have a little more specialized hardware, but then you get the 3D printing accuracy from something that you would want to turn a bunch.
So robots can move around on wheels. So these are just two stepper motors hooked up to wheels, and this is Susan's kitty bot. She built for NodeBots Day. So two servo motors, they move the wheels independently. You move both motors forward to go forward, both motors backwards to go backward. You move one of them to turn. You move one of them forward, one of them backwards to turn really quick. And there's like a little ball caster, which is kind of like if you ever use like ball deodorant or something. Like it's kind of like that, and just it's upside down and it rolls really easily. It's made out of a ball bearing and a 3D printed casing, but you can buy them pre-made or whatever. It just increases the motion, or like it slides around pretty easily. You can put robots on tank treads, and tank treads are kind of like wheels, but they have larger surface area and better grip. And this happens to be I believe the robot that Rick Waldron used to propose to his wife. So there it is with the ring, and she said yes. Surprisingly. But there are bipedal robots, which just means like 2-footers. I mean, not 2 foot tall, but like 2 feet, And they walk awkwardly, but depending on how many servos you have, they can have really graceful or funny gaits. They're not super practical, but they're cool. You can mix wheels and bikes. And create like hipster fixie bots. This one can pedal and wave, and it's really impressive, but it's a hipster bot. You can have robots that have 4 feet, and they're quadrupeds, and you can have robots that have 6 feet, and they're hexapods. And like usually these like multi-legged bots are patterned after some sort of animal movement. This one, surprisingly, is called like the turtle bot, I think. It's pretty cool. Rick has a quadruped that's a little bit different than this. Looks like a creepy spider. Over in the robotics table, you can come take a look at it. And it's really cool actually. There are, some of you have gone to the drone room, there are robots that fly. Like every time I see one of these, I think of like the Terminator, like Rise Against the Machines and those things, and the Matrix, but it's just me. They don't sound creepy when they're flying at all. Not all robots like move the whole machine. You can have also stationary arms that reach out and grab things. May or may not have a pneumatic robot arm working at the robotics workshop table soon. We'll see. If it all works out, it does. And then on the end of those arms, like this is a servo that's been converted into a robot gripper arm just by, it shows you how like articulation works. You just have little claw things and like a free spinning cog and a motor turned cog, and you have a gripper. It pinches stuff. You could 3D print this today and grip stuff. Because that's what you do with a robot gripper, presumably. You can, like most of the motors that we've seen, just go round, you spin me right round, baby, right round. But there are different ways of converting that motion into like linear or like different kinds of motion. And this is one, it's a linear actuator based on a screw drive. So there's basically a screw and a captive nut, and it just moves back and forth. That's one way of doing it. You could also do it with like a rack and pinion where you have the motor driving a gear and like sort of like an unrolled gear that moves back and forth. You know, there are many different types of mechanical actions, and if you want to make a robot that moves a certain way, I would encourage you to check out this book that's free online, 507movements.com. It was published in like 1868, but it like details like pretty much every type of robot or any kind of mechanical movement you would want. And as a bonus, it includes like animated GIFs for a lot of them, so you can really visualize like if you want a robot that does this, you just build these two rack and pinions and make them move in tandem. It's really cool. Like, mechanics hasn't really changed that much, and it's very useful and cool and free. So the other part of robots is are sensors, so like things that take in information from the outside world. There are a number of them. Micro switch is probably the most popular. It's just a switch. You bump it, it goes on and off. A lot of times people use these as like bump sensors, so like you have a little, plastic stick or something, it bumps, and the robot realizes, oh, I hit something, I better back off. A lot of the 3D printers and CNC machines that we have, laser cutters and stuff, use these as end stops. So when the stepper moves the print head all the way to the left, there's a little micro switch, and it goes, boop, oops, I've gone to the end, and knows to back off. It's probably the simplest sensor you could put on your bot. Do you have something to say?
I was going to say, like, the switch is like the most basic electronic component. You can use 2 wires.
Yep.
So some of the, what are they called, beam robotics, like trying to use no CPUs, just electronic circuits, are going to have 2 basic spring wires, and when they touch, now you have a bump sensor, so they know to turn around. And it's really easy to code too, so any Arduino can do this, or you can even use a bunch of transistors and build some logic, censoring logic with just
stuff.
Yeah, just, oh, I should turn around.
So a lot of you want to make robots at sea, and one option is cameras. If you've seen like Raquel's presentation, she talks about like stereo cameras. It used to be that you could get like a pair of like black market human eyes cheaper than like small cameras for robots. It's no longer the case, but they are still hard to program. There's a lot of stuff in OpenCV. It's Open Computer Vision project. It takes a lot of CPU, but you can basically like, it'll recognize objects and like, follow yellow balls. There's also other options like connect libraries and Sony stick on a ball on a stick, whatever they call that. Like
there's also,
iToy.
There's also Simple CV, which is an alternative library. And I don't know if it's based on OpenCV, but if you've never done AI programming, it's actually really easy to say, find a face in this picture. Oh, I found a face. So it's great.
Does it still require lots of CPU? You probably couldn't do
probably
it with Arduino, maybe like Raspberry Pi or something even beefier then.
Yeah, definitely beefy. There is the CMU cam, which is a pretty hard to find hardware, and they're just making the CMU cam 5, but actually has dedicated hardware that does face tracking, and you can train it. And it just says, there is a purple dinosaur in the upper right corner of my camera.
Kill Barney.
Yeah. You have to go
people remember Barney. Oh yeah, okay. My people. Accelerometers. So these are, you have them in your phones, and they basically detect. What's going on?
Everything's fine, don't worry about it.
The robots are coming. Accelerometers detect motion in the X, Y, and Z coordinates. So if you take your robot and you shake it this way, or like you want to have like stop motion detectors or whatever, we have a bunch of these in the Tinkerkit form. I don't know what you'd use it for, like some sort of crazy arm that waves around or something. Figure something out. You can use it to control it so that if you like, swing a stick this way, the robot will go this way. But yeah, basically they track like G-forces on the chip. It'll tell you like how much force is applied this way, and you can use it to control things. GPS modules, so they basically, it's like robots that know where they are all the time, that are creepy, and just like, you can use them to route out things around your neighborhood. These are pretty cheap now. You can get them for, I don't know, maybe 30 to 50 bucks on different retailers like Adafruit. Sorry? Taco Bot, yeah. We have friends that are working on a thing on a wheelchair base called Taco Bot that is meant to go and deliver tacos throughout the neighborhood. Let's see that one coming along. I'm sure you'll get an update next RobotsConf. Reflectant sensors. These are basically like, I guess they measure reflectance of materials they're put up against, but most normally they're used as like line detection bots. So if you've entered like a robots club or competition before, usually like one of the simple things they have is like follow a line, and this is what you'll see on there. And it's just like usually like you use them in rows of like 3 to 6, and they will detect a line, and you can program the robot to follow along the line.
It's kind of like the bump switch, right?
Yeah.
It's using light instead of physical contact. So for let's say interesting terrain, it's better, right? Because you don't have to worry about being rubbed or getting caught.
If you wanted to do like a carnival ride around your neighborhood or something, like you could kind of just draw a black line out and put like a wheelchair base and sit and like drive through like a dinosaur forest or something. Be cool. Just ideas. These are ideas. Sonar rangefinders just are basically proximity sensors. They work like bats, and if you've seen Raquel's presentation with the bat bot, that's the thing it is. And so like it'll just send a sound, and it'll bounce off something, and it'll come back and go, and it'll absorb the sound, and it knows how far away that thing approximately is. The dolphin bat sensor. Light sensors, so these are just luminosity sensors, kind of like inverse of LEDs that kind of absorb light and can tell how bright something is. If you wanted to make like a robot that sits in the middle of your kitchen and then scurries under your refrigerator when you flip the lights on, you could do that with this.
I actually am in the middle of building a digitalized foosball table using lasers and light sensors. So whenever somebody scores, it breaks the laser beam, and then the Raspberry Pi says, oh, the signal's broken, so it actually posts to our servers and updates the score. Super simple to work with, too.
Nice. Thermistors are basically temperature sensors, so if you want bots that like sweat or something, I don't know what you'd use this for. When the temperature hits this much, sweat. But there are available. I think they're in the Tinker Kit as well. You could use them for finer operations like roast your coffee bot, things like that as well, I imagine. You might want to use like a digital thermometer for that, though, actually, something more precise. But they're cool. Gyroscopes are kind of like accelerometers, except they work on tilt, so they're kind of like those old Mercury switches. So if you wanted to have like a controller like on your wrist and you go like this, you can kind of make the robot tilt that way, or see if a robot will know how it's oriented with this gyroscope, and you can flip it upside down. It's like, oh, I need to get back up again. I'm a turtle.
Yeah, so the accelerometer, the gyroscope, and the GPS are sort of core to drones, and the main purpose for putting those on drones is to fix position. So it says, stay right there. By knowing its rotation, acceleration, and fixed position with the GPS, it says, oh wait, it's getting windy, I should go back. And you can take that, you can take that same logic and apply it to, I don't know, a roller bot with the one where there's only one giant wheel or one of those Omni wheels, and you can balance it. Yeah.
That's about it. So what happens at the workshop? Well, glad you asked. We will help you. There's no workshop. I mean, just come like the hack day, open hack thing. That's what I meant. We will help you to build your dreams. Within reasons, we probably aren't going to build this thing, but we can get you started for sure. So, this is all the stuff we have, almost all the stuff we have. There's, so like Arduinos you guys have, there's a bunch of Tinker Kit components. We have a couple of Mindstorms. I brought a bunch of woodcut SumoBot Junior kits. I think there's like 50 of them. There's more than 50 of you, but team up or be the first to grab one. And they're just basically like slide together robots, looks like that. It's a good start for some people. Other people might want to go whole different directions. Raspberry Pis, Beagle Bones, popsicle sticks, cardboard, rubber bands, strings, glue, and zip ties. There's no limits. Just use anything you see laying around, as long as it doesn't look expensive and doesn't belong to you or Chris, I guess. But not Chris. Like, within reason. Just like don't start hacking up the tables, I guess. Maybe.
Don't set the place on fire.
Don't set the place on fire. Or write on the walls with Sharpies. Sorry, I told them already. But Plus many cool and inspiring demos by us and you. So hope to see you there. See John and myself, and anybody else who's around, and help you get stuff done. Thank you.
Thank you all very much.